Okay, ladies and gentlemen, we're taking a look at our second last unit, I think. There's going to be more to come with this package, however. If you're at home, you're going to have to download these sheets or just take a look at them and do your work on another piece of paper. I can live with that. You'll get a package of these when you come to class on Tuesday. Yeah, I see cohort B on Tuesday. Okay, so this is chapter 7. We're doing algebra of quadratics, and these next 2 units are very important for your grade 11. You have to keep up with these. You have to know what's going on with these, and you're going to be tested on this next week. So let's start. Prerequisite skills. These are skills that we need before we can start. These are things that we need to understand before we get into the new stuff. So, you've heard me use this word before, a numerical coefficient. A numerical coefficient is the number part of a variable term. So this is 3x. Now, things are going to get tricky now because we've always looked at that as 3 times x. And now I'm going to tell you that that is 3x. And what it means is 3x means 3 times x. It most certainly does. But it also means x plus x plus x. It means 3 x's. That's exactly what it means. It means that there are 3 x's there. Now, the numerical coefficient is the 3. That's the number part of that term. And we give a very special name, numerical coefficient. The numerical coefficient of negative 5x is negative 5. And this is very much the same as saying that I have 5 negative x's. So if blue is a negative, I've got a negative x, and a negative x, and a negative x, and a negative x. Do I have enough? 1, 2, 3, 4. No. And a negative x, which means the same as negative 5 times x, or 5 times negative x. But that looks weird. 5 times negative x looks weird. So we put the negative out front, and we put it with the 5. And that becomes our numerical coefficient. The variable part is the letter. The variable part in this one is the x. So a polynomial can have 1 term. We call that a monomial. A polynomial can have 2 terms. We call those binomials. Or it can have 3 terms. We call that trinomials. And then it can have 4, 5, 6, 7, 8. It can have up to as many terms as you want. And you know what we call those? Polynomials. So we need to understand that monomial, mono, means 1. We need to understand that binomial, bi, means 2. Bicycle, bi. And trinomial, tricycle, means 3. And poly means many. Poly means many. Okay? So, identify each expression as either a monomial having 1 term, a binomial having 2 terms, a trinomial having 3 terms, or a polynomial, and in this case we're going to say more than 3. That's what we're going to consider a polynomial at this point, more than 3. Because to be honest, a binomial is a polynomial. It's just a polynomial with 2 terms. A monomial is a polynomial. It's just a polynomial with 1 term, okay? So there's special subsets of polynomials. So how many terms are here? Well, there's 1 term, and there's 2 terms. So there's 2x squared, and there's 3x. We call that a polynomial, but it has a special name. It is a polynomial, but it has a special name. It's actually a binomial. So for the case of this particular question, we'll refer to that as a binomial with 2 terms. In terms of this question, 5x is a monomial. This one, I've got x squared, so I've got x and I've got numbers. These are 3 unlike terms, x squared, x's, and numbers. They can't be put together. This is a trinomial. And the last one has x squared, x squares, numbers, x, y's, and x's. None of these are like terms, so this is what we're calling a polynomial. More than 3. It's not one term, it's not 2 terms, it's not 3 terms, it's in fact 4 terms, and we're going to call that a polynomial. Okay. And again, this is a review of information that we should know. Multiply or divide the following. So I've got 2 times negative 3p. We've been doing a lot of work with this during this week and last week. So 2 times negative 3p means negative 3p plus a negative 3p. That's what it actually means. We're never going to write that. What we do is 2 times negative 3 to get negative 6p. And that's what we've got here. We've got negative 3p plus another negative 3p gives us negative 6p. And that's how that works. So how do we multiply these guys? Well, you got to take into account the negative. So it's negative 2 times negative 5. It's going to give you positive 10q. Now the next one's a little bit different. I've got numbers that are being multiplied and I've got variables. What I like to think about in my head is this. I put the numbers together and I put the variables together. Now I do that in my head. I don't write it down. I'm just showing you what I'm thinking. And what I do is 2 times 3 is 6 because the numbers multiply together. And then the x times x, I need a way of saying x times x, and that way of saying it is x squared, which means that we take the base and we multiply it by itself so that there's 2 of them. And that's what this is, taking x, multiplying it by itself so there's 2 of them. So it's x squared. Let's take a look at this one. Negative 12x divided by 6. Well, we could rewrite that like this if we wanted to. And if I look at it that way, you notice that the 12 divides by 6 to give 2. A negative divided by a positive is a negative, so it's negative 2x. You certainly do not have to write this middle step. You can go right to the answer. But I'm showing you what I'm thinking. Next one, I've got 25y squared, negative 25y squared over top of negative 5y. Now, I'm going to be honest with you. This is what I'm thinking. I've got a negative 5, I've got a 5, I've got a y, and I've got a y. That's all on top. 5 times 5 is 25, negative times positive is negative, and y times y is y squared. And on the bottom, I've got negative 5 times y. So really what's happening here is this y on the bottom and this y on the top are going to reduce. This negative 5 on the bottom, this negative 5 on the top are going to reduce. And I'm going to be left with an answer of 5y. That's all that's left over. Now, you certainly don't have to show this step, but that's what I'm thinking. So when I do this question, what I'm thinking is 25 divided by 5 is 5. Negative divided by negative is a positive. Y squared over top of y, well, if I have a y times y on top divided by a y, they're going to cancel, leaving me with a y on top. And that's the way that works. Let's look at the next one. I've got 10x squared over negative 2x squared. Well, 10 divided by 2 is 5. A positive divided by a negative is a negative. So the answer is negative 5. X squared divided by x squared, well, there's 2 x's on top being divided by 2 x's on the bottom. They cancel each other out, and my final answer is just negative 5. And that's how that goes together. Okay, we're going to come and take a look at question number 4. We're going to simplify each expression. But what we have to remember is only like terms can be added or subtracted. So when I look at this, I have to decide what the like terms are. 2x and 4x are like terms. They're x's. And 6 and 8 are like terms. They're numbers. So the 2x and the negative 4x go together to give me negative 2x. And my 6x and my 8x go together to give me 14. And there's nothing more I can do there. They're not like terms. I can't be adding x's to 14s. I can't be adding x to numbers. You heard your teacher talk about this in grade 6, 7, 8, saying you can't add apples to oranges. Well, whatever. This is an x. These are numbers. They can't go together. Let's look at the next one. I'm going to zoom in a little bit here. So what are my like terms? My x squared are like terms, and my x's are like terms. You can't add an x squared to an x. They're not the same. But if I have 2x squareds and someone gives me 3 more x squareds, then that would give me a total of 5x squareds. And if I had negative 4x's and someone gave me 11 more negative x's, I would have 15 negative x's. Those two cannot go together. They are not like terms. X squared and x are not like terms. They both have the variable x, the letter x, but it's not the same. There's a difference. And then the last one. I've got a bracket here. That sometimes gives us a problem. Well, what we know is this bracket means that I'm supposed to take x plus 4 and add everything inside the bracket. So I'm supposed to add x squared, add a negative x, and add a 5. So I don't need the brackets in this case. I can get rid of them. Some of you have learned to get rid of the brackets by putting a 1 here, the invisible 1, and you distribute. And that gives you the same result, and that's fine too. Now you look for like terms. Well, the x's are like terms, so x subtract x goes together. And your 4 and your 5 are like terms. And your x squared, it has no friends. It's like a math teacher. It has no friends. It's so sad. So it just gets left alone. X minus x is no more x's. 4 plus 5 is 9. And you are done. That is the last of that question. I'm going to pause the video here and be right back.